All right, hello everybody. Thanks for joining me for this talk. My name is Dominic Eskofier, and as the lovely moderator already told you, I'm heading up the virtual reality business at NVIDIA for the European, Middle Eastern, African, and Indian region. And while my lovely tech colleague here is setting everything up, I can tell you a little bit about my background. So I'm a huge virtual reality enthusiast. I became such an ambassador for this new technology when in 2012 I tried the original duct-taped prototype of the Oculus Rift back when it was still in Kickstarter. And it was literally a piece of tech that was held together by duct tape that came out of a garage in California. And some of you may know this story. Oculus in 2014 got bought by Facebook for $2 billion. And now virtual reality is in everybody's minds. And ever since I had my first virtual reality experience, I became this huge VR enthusiast. I did a lot of things on the side to push the medium because I believe, and NVIDIA believes, that virtual reality will become a pervasive technology. It will change the way we work, we communicate, and how we... I'm just going to help you out here. There we go. And so what I did is I started one of the largest unofficial communities on the internet, which is the Oculus subreddit on reddit.com. I also started, together with other people, a non-profit initiative called EUVR.org that helps to push the envelope for the European VR industry. And right now, I'm heading up the VR business for NVIDIA in these regions. And today, I'm going to tell you about the journey to Holodeck. And this journey to Holodeck began in the year 1974. And some of you may remember the original series, which is Star Trek. And the idea for the Holodeck was born in 1947 with the animated series in Star Trek. And what the Holodeck does, it's a complete replication of the real world. And the question that many people have or had ever since they saw their first holodeck was, can the holodeck become a reality? Can you simulate a world that looks right, that feels right, that sounds right, and that just acts right? So you are truly immersed in a virtual world. And these are some of the questions that drive NVIDIA. We are a company that's driven by the hunt for photorealistic graphics. But we also believe that virtual reality is a big technology of the future. So we're tackling some of these other challenges as well. So let's look at the 70s. Some of you might know this. Virtual reality is actually a pretty old technology. It was the first virtual reality device was called the Ultimate Display by Evan Sutherland in the late 60s. And the device looked a little bit like this. If you look at the video, it was a contraption held up by wires. And that's why it was called the Sword of Damocles. Essentially, it was hovering above your head. And if some of you are complaining about motion sickness in modern devices, you can imagine what this guy had to go through. So that was the technical side in the 70s. But what did computer graphics look like in the 70s? What you can see here is Indiana Jones, just in case you didn't recognize him, rendered in 28 pixels on the Atari 2600. And I have a question for the audience. How many people have played with the Atari 2600? Yes, there's some fans over there. So back in the days, both the technical side and the content side were a really tough challenge to solve. But due to a couple of advancements in the 90s, largely driven by NVIDIA, we are now at a point, or we were then at a point, where we could render 3D worlds in a more realistic way. But that looked a little bit like this. This is Doom from 1994. And so you see that the graphics were, well, we had a 3D world, but they didn't really look photorealistic. And also the VR technology, it got better from the 70s, so better tracking, higher resolution, but compared to today's devices, it's really not quite on point. Let's jump to today. Here you see a screenshot from Paragon, which is a game made by Epic Games, built on Unreal Engine 4. And in this one, you see a huge step from Indiana Jones that I just showed a couple of slides before. We made extremely large advancements in terms of rendering photorealistic scenes. So we are already on a good track in terms of visual quality today. And that is largely driven by a large product range of GPUs. So NVIDIA has a lot of GPUs, mid-range, low-end, but also high-end, up to the Titan X, which is the king of the hill in our product lineup. And this GPU has 11 teraflops of computing power. Just to put that into perspective, the first computer that broke through the 1 teraflop barrier was the ASCII Red in the late 90s. And the ASCII Red had 1.3 teraflops, and it filled about the size of this room, so about 2,500 square feet. And all of this, almost 10 times as much performance we have today in our modern GPUs. So we are really able to visually replicate real scenes in virtual reality running at 90 frames per second. But virtual worlds don't only have to look right, they also have to feel right, act right. They have to be physically simulated. So if you are in a virtual reality experience, water has to look like water, has to behave like water. Fire, smoke have to behave like you would expect them from the real world. Because if anything in a virtual reality experience is not as you would expect it from the real world, your sense of presence will be immediately broken. This fragile sense of immersion in a virtual world will immediately get lost. So it's really important to also physically simulate anything that you know from the real world. And we have a software development kit called the GameWorks SDK that allows you to physically correctly simulate objects in virtual reality. And you can go even as far as simulating real fire and real smoke. And what you see here on the screen, every single pixel in this scene is physically correctly simulated at 90 frames per second. Take a close look at how the fire and the smokes interacts with objects. So this metal bar that you have here, it will heat up. It will bounce off the smoke and the fire in a way that even in virtual reality, it becomes a really believable experience. And again, this is all running in real time on a Titan X. But virtual worlds also have to feel right. And we are very happy that a lot of developers out there in the virtual reality industry are adopting our physics SDK and our physics haptics layer for driving more believable virtual reality experiences. One of those partners is called Haptics. And what they're doing is they're building a haptic glove that allows you to actually feel virtual objects just like objects in the real world. And a couple years down the line, or maybe just a couple months, they are working on a full haptic suit for virtual reality applications. So imagine you strap on one of these suits, a haptic glove, and suddenly you will feel the impact of bullets or heat or cold in a virtual reality experience, which is very important. Because, again, for virtual reality, you want to simulate every single sense that the human body has. But one important thing that many people are forgetting about is audio. So, of course, virtual worlds also have to sound right. And what we're doing is we're developing a software development kit which is called the VRWorks Audio SDK, which allows you to more realistically render how sound propagates through a room. So what you see here is how it's traditionally being done. There's a direct positional audio from the sound source to the viewer, to the player. But this is not good for VR. In VR, you'll immediately hear the difference from a positional audio as compared to a spatial audio that's all around you. And the reason for that is that sound waves propagate in a different way. And if you want to simulate this realistically, you have to take things into account like absorption, reverb, or occlusion. One example is for the occlusion is the black ray that you see up here. And what you also see in this animation is how we are tackling the problem of audio and virtual reality. We are tackling that by using our existing optics ray tracing engine that we've built for realistically ray tracing photons in a room. But now we're using that existing foundation and path trace audio. And this is a really, really important thing. The chief scientist of Oculus, who's called Michael Abresh, said that audio and virtual reality is not an addition, it's a multiplicator. And NVIDIA fully agrees, and that's why we're putting so many resources in not only making it look right and feel right, but also sound right. But you also want virtual worlds to behave exactly like the real world. If I'm talking to an NPC, which is a non-player character in VR, so an avatar, you also want any AI-driven avatar or NPC to react to you in a very natural way. And I've pulled up here an app from Ubisoft which is called Star Trek Bridge Crew. For those of you who haven't played it, it's a ton of fun playing with friends. So I really advise you to take a look at it. But if no friends are online at that moment, you can replace some of your crew members with AI members. And what we've done is we've helped Ubisoft and IBM to implement Watson speech-to-text recognition in Star Trek Bridge Crew. So imagine this: you're on the board of the USS Enterprise, and you're shouting in the heat of the battle. You're shouting commands to your AI-driven crew members, and they then react in a very natural way by just recognizing what exactly you've said. And IBM is leveraging NVIDIA technology and NVIDIA GPUs to make that possible. And things like this, so this is one of the first AI implementations in consumer games for virtual reality. But you will see many, many more of these applications in the future as AI, deep learning, and machine learning will come into the realms of virtual reality to make those worlds more believable over time. So this is how we simulate the reality with our software development kit called VRWorks. We're capturing the visual side of things with the VRWorks graphics SDK, which allows you to drive virtual reality experiences at higher performance, at a constant 90 frames per second refresh rate, which is very important for a believable and also comfortable virtual reality experience. We're simulating sound through our VRWorks SDK. We take into account things like absorption, occlusion, and reverb to make virtual worlds sound just like the real world. We've implemented the physics haptics layer so that haptics providers, people who are building haptics gloves, can tap into our existing infrastructure and drive, again, more believable virtual reality experiences. And then we have one additional thing, which we call the VRWorks 360 SDK. So if you want to do a virtual reality experience, you can do two things. One, I've explained at length now. You can do a computer-generated representation, essentially a CGI version, where you build the whole world in a real-time engine and then display it on an HMD. What you can also do is you can capture real-world scenes with multiple cameras, which is often called 360 video. And you can do that in monoscopic and in stereoscopic. And what we've shown at GTC this year is real-time stitching of 360 content on the GPU. So 8 cameras in stereo can be stitched in real time. Which means that if you are a 360 production house, instead of going to a scene, putting up your 360 camera, taking that footage back to the office, stitching it, and then finding out that your production shot wasn't quite on point, because maybe the actor was standing too close to the camera, or maybe somebody was moving through the seams in a 360 video. And with the VRWorks 360 SDK, you can do all of that in real time on the production shot. So you put your camera there, and you can immediately, in an HMD, see exactly what the shot is going to look like, which drastically cuts down on production time in 360 content production. So we're doing a lot of things on the technical side and also on the software side to make the Holodeck a reality. And we're actually working on something that's called the NVIDIA Holodeck. And we imagine it to be the collaborative design tool of the future that's also enhanced by AI features that will, in the end, finish your design for you. And what is really important are, of course, photorealistic visuals. If you're designing a product like a car, for example, you want your visuals in the design process to be on point. There's no margin for error when you're designing a 100,000 euro car. You also want to have collaboration. So you want to be able to invite, for example, a designer from Tokyo together with an engineer from San Francisco so they can collaboratively work in a shared virtual environment. And you also want this whole world to react physically correct. So as you grab the steering wheel, you don't want your hands to clip through that steering wheel. You want it to be on point so that it's more realistic and your sense of immersion never gets broken. And we've put all of this into NVIDIA Holodeck, which is available for early access. As you can see here, you can even make the design process more intuitive by allowing people to take off individual parts and examining them, measuring different sizes, drawing something on a whiteboard, talking to your colleagues, drawing on the car itself to make the whole design process more iterative and more intuitive for your colleagues from all around the world. You can even do crazy things like cut into the inside of the car to expose the engine block, to make changes on the individual parts of the car. You can explode the car so you can get a better view of the individual parts. And we also want to enable people to render models at a very high visual quality. So what you see here is a model with over 50 million polygons, rendered in 90 frames per second for virtual reality. You can change the location, so you can take a look how this car would look like in a different environment. You can change the colors of the car. You can do anything that a modern design process involves. For those of you who are interested, I invite you to go to nvidia.com/holodeck and sign up for early access. So let me recap this real quick. NVIDIA is really enabling the whole virtual reality and augmented reality ecosystem. We're building the hardware, which is our core business. Our core business usually isn't applications, but we want to show the world what's possible in virtual reality. So we're also building application to really spearhead those kind of experiences. And then we're building software development kits like VRWorks to help developers shorten the time that they need and lower the amount of resources they need to make better virtual reality experiences. But we are just getting started. There's a lot of technical challenges that have to be solved for virtual reality to become even more immersive. And I'm not going to go into too much technical detail on this one. I invite all of you to watch Morgan McGuire's talk called The Virtual Frontier. He's a colleague, he's working in research and development at NVIDIA, and he's really pushing forward the envelope for virtual reality. What you see here, just real quick, is a headset that is very small size. So we're working on making the ergonomics for virtual reality even better. And then we're also doing things like perceptual optimization, where in this case, only the part that the user is looking at that very moment is rendered in high resolution. The rest of the image is rendered in lower resolution, which solves a lot of performance challenges in virtual reality. These are just two examples of how we're driving forward the virtual reality industry with research and development on top. So I want to wrap up this talk with an open question. Is a real holodeck close to reality? And I just want you to take a step back 15 years ago to GTA 3. The car models that were rendered back then were pretty low res, pretty low quality. In 2017, 15 years later, we're already way advanced in terms of visual quality. So what are the next 15 years going to look like? I just want you to take a look and extrapolate from the big steps, the huge leaps we made during the last 15, 25, 40 years in terms of visual quality, and then extrapolate to the next 15 years. And we at NVIDIA believe that a holodeck is definitely a possibility within the next couple of years. Thank you very much.